Hello, welcome in 2, where we're going to start writing SQL. It's going to be a lot of fun. We're going to learn a lot. So here we go with putting SQL clauses into practice. The first thing I want to just give you an overview of the material that we're going to cover and in what order. So, misspelling there. What we're going to learn in this section, first we're going to cover the very basics. So select where, group by count, basic aggregations. We're going to work on building the mental model of SQL. And we're going to try to take a unique viewpoint on it. Most common joins, so inner join, left join, self join, this is all about bringing data together so we can use our select where, group by count, other aggregations. Then we're going to take a little bit of a step back. I just want to drill one thing into your head, that everything is a table. You can nest queries, and you can sometimes save a lot of time by just selecting from inner queries. So I want you to get a handle on that really early and just start thinking in terms that everything can be selected from for the most part. After that, we're going to take a break, look at some common mistakes that I've made over the years related to joins and different things you might be filtering on, but you may not actually be, or data that you might have thought you brought into the picture with a join, but actually never made it because of the way you joined. And then we'll talk about more advanced filtering. Also look at the having clause, which is a way to filter on aggregates. So let's take a look at select where, group by, and count. Again, this is all about building our mental model of SQL. So before we actually start writing, quickly select. It's literally choosing something. Now the key thing is when you choose something, you may or may not perform an operation or an aggregation on it. So select is the fundamental clause. Where is filtering, could be filtering a date, it could be filtering on a number. And the close cousin of where is called having, which we'll look by later, but it just lets you filter on aggregations. Count is an aggregation. It's a very common operation, especially for debugging or trying to understand your database. And even just doing business intelligence or data science. Count, very important. In this video, we're just going to look at basic counting, but then we can move on later to counting distinct items. Group by. Very, very fundamental. You're going to run into errors a lot that say something about group by. We're going to cause those errors, look into them, and figure out how to take care of them. Basically, group by is when you've selected a column, or you've selected a column and at least maybe other columns that need to be computed something on them, like a count, a sum, an average, and you have to basically tell the database, I want to perform these operations on these columns, but I want to group it all out by this column. Kind of like a pivot table almost, where you have rows and then operations on the columns. So let's go to PG admin, and we're using the DVD rental database again, which we installed in the prior video. Okay, so we're thinking about selecting, and I also want to keep the idea of what is in a row in your mind. So how do you figure out what columns you can actually use? So select star from payment. Star just means every column. So in this case, we're not using an alias. I could use an alias. Let me just hit F5. That runs the query. So keep in mind, I could call payment P. Now I could still run it. And as we get into more complicated SQL, you could say P.star. That'll also have the same effect, so P.star from P. For now, we could just leave it like that, and that's just fine. So, what's in a row? We have a payment ID, and then we have different kind of foreign key columns, meaning will key into a customer table. This will key into a table of staff who rented the DVD to the person. How much they paid, the payment date. Notice the payment date, it goes down to the very granular year, month, day, time, second. So it's very, very granular. So if we wanted to, start making some selections here, and I believe if you're in PG admin, Command K will comment that out for you. So let's write a more deliberate selection and just illustrate limit and ordering clauses. So now you see we have two columns we selected. What if we wanted to actually go ahead and order by the second column? Meaning I wanted to view this column going from high to low. We're going to use the order by clause here. And the way I like to do it, to be less verbose, is reference the column index. So we're not using zero-based indexing in SQL. This is column 1, column 2. So I can say order by 2. Descending. Okay, and just one word, if you order by 2 without the descending clause, the default ordering is always ascending. So it's going to go from, the lowest number to the highest number. So just remember, in most relational database systems, when you order by something, the default will definitely be low to high. You have to specify DESC if you want to change it fundamentally. Now, if we had more columns, let's add another column. First of all, what do we have? Okay, we can get an amount here. So p.amount, run the query. If we wanted to order by multiple columns, we could say order by 2 descending, 3 ascending. And then you have kind of these, multiple ways to order. So for instance, we're looking at column 2, which is 599, customer ID, and now column 3 is going up, ascend. So let's just build upon that very quickly here and introduce the where clause. Now, let's take this query, copy it down, and Command K on a Mac comments it out up there. Now, we have 3 integers here for the most part, so why don't we take a look at filtering rental amounts that are, let's take a look at the values. Okay, anything that's under $1, let's filter that out. So we're still going to keep our select columns from and our order by. Now, the where clause goes kind of in between the from and the order by. And we're going to say we're p.amount. Okay, so now we've got that. If we wanted to kind of nest conditions, or not nest, or just bring in many, we could say p.customer ID. And let's take a look at that. We'll say greater than 589. And of course, this could be or, if you wanted to sort of, make that distinction. So, the where clause could also apply to operations with dates. So let's take a look at our kind of columns again. I'm just going back, selecting it, and running it again, which is kind of nice about this environment. So let's say we wanted to use a where clause on the date. We look across all our dates. They appear to be mainly in February. Let's see if we could find something to distinguish them on. Mainly February 2007. Okay, so let's just filter all dates so that the month is February. So yeah, we've got our amount filter, we have the customer ID filter, and we can say or, say and. So what I'm doing here is extract. It allows you to pull out many date parts, such as day, week, month, quarter, year, from dates, and it outputs an integer. So in this case, month would be take a value from 1 to 12, and now when I run that, you'll see that also put in date. So extract month from p.payment date equals 2, and we need to put this right. So you see here the difficulty in nesting logical clauses. We want a criteria of the payment date is equal to 2, which is not returning. And we also want the amount to be greater than 1 or customer ID greater than 589. Now this or clause at the end of the statement is creating a problem because we're saying that we're not chaining the conditions properly. So if we really wanted to, let's just drop that for a second. And we do see here that now we have all dates. The month of the date is in February anyway. So that's something you want to be careful about. I'm glad I illustrated the problem. Really make sure as you're creating multiple where clauses that you understand what's happening. Because when you switch from multiple and clauses, which are kind of like I want this and that and that and that, and you throw an or clause in there, you have to be careful that you don't negate or throw out some of the filtering you might have thought you were doing. So that's a simple example of a where clause, some ordering clauses. And one other thing to mention, as you start adding more columns, if you're referencing the ordering clauses by their kind of integer column indices, they might change as you add columns. So keep in mind, you still can say, well, I want to order by that, and I want to order by this, ascending. So while it's convenient to reference the column indices, if you start adding columns or doing more aggregations, which create more columns, you can get into a little bit of trouble there. So pick your favorite way. Depends on the complexity of the query. You can use the numerical indice or the column name. So let's finish this video with some discussion about grouping. And I think I'm going to do, so what if we wanted to answer a very simple question? We just wanted to see the number of rentals by day, and we wanted to view the day with the most rentals. So let me just write some code here and I'll explain it. So that error, let me just go back to that error. Missing from clause entry for table P, we had referenced an alias we forgot to set up. So P. Now it knows what P is. It's payment. Reference the payment. So, and let me just show you what would happen here if we actually count star. First thing that's going to happen is you have a column that you haven't done an aggregation on, and you're counting it. So what you need to do is group by it. So we can say group by 1, which is the first column. Okay, now here's the thing. Remember way up here I said what is in a row? In this table, every row is a record of a rental that's down to the second almost. So really we want it by date. And a handy way to go from the kind of the very granular date time here to just the date is colon date. So let's try that. Okay, now we're in business. We're not ordering by anything actually. So let's order by 2. Ascending. Keep in mind that the default ordering is ascending. So there we go. The date which had the most rentals was April 40th, 2007. And so that's kind of neat. Take one more example here just to further practice our grouping before we move on to, joining data. Now, what if I wanted to, let's take a look at our table. And I think array ag is kind of a fun thing sometimes. Wish I had a little more time. But let's get it done. So let's say I just wanted to get customer sums. How much money did a customer spend on renting? So now it's going to get mad at me. If I hit F5 to run it, again, we have to group, right? Since we're performing an aggregation on a column, we definitely need to group by it. So I'm going to group by customer ID. And I'm also, you can just say 1. I like that. That's my style. So now we have, essentially we have the amount they're spending here. Now, what if I wanted to get all their rental IDs or their rental dates for some reason? What was it called? The P.dot payment date. So I could use something called array ag. And that's kind of neat. Sometimes you'll have to, in the course of, business intelligence or data science, you'll need to structure the data in an array. And if we go back to our date operation there, that gets a little bit cleaner. So here you can get the customer ID, and instead of summing their payment amount, we're actually just converting the, all of their dates for which they ordered to an array. So that might be handy for some processing in Python or R or something like that. So that's always an option. You can take a column and you can stuff some attribute of another column into an array that returns it in a single column.